Hello, everyone. My name's Ed. Thank you very much for joining me. As I said, hopefully you're expecting this talk. My talk today is how to keep your apps secret. Secret. I think it should probably be how to keep your app secret a secret, but yeah, ignore the typo. Thank you for joining me. Please make yourself comfortable. We've got a lot to go through, so by all means feel free to take photos, although these slides are already available online and I will share those shortly. So let's get it over and done with the very boring bit straight away. Who am I? My name's Ed. I am a mobile lead at Kraken, not the crypto exchange, also not the rum company, but Octopus Energy Group, same place John O'Reilly works. I'm a mobile lead there. I've been there for 2 months. It's a wonderful place. Highly recommend it. I'm also an Android GDE. I've been doing Android for forever, and I like to talk about mobile security, which is presumably why you're all here. I'm available on all good social media and X for mobile security stuff, dog pictures. I always shoehorn a photo of my dog in there somewhere. And yeah, thanks again for coming. I'm really, amazed that you've all turned out, so thank you. Let's kick off the talk with a kind of obvious statement that every app developer has secrets. Now, when I'm talking about secrets, I'm not talking about the thing that you've got kind of hidden, shoved at the back of your shoe cupboard. I'm not talking about kind of the spaghetti code that you've written and forgotten about. We're talking about kind of secrets in our code bases, secret things that we need to access that are technically things we don't want other people to know about. Let's have a quick kind of look at what some of those things are. So some of those things might include API keys, secure strings. Like I said, anything that basically we don't want to be in the hands of somebody else. If you do a rudimentary search on GitHub, you can find loads of great examples of secrets, which people haven't secured. So this talk is very much for the people that want to know how to avoid being kind of in this position where you're exposing secrets and how to remove them from your code base. But first, before we kind of discuss how we're going to do that, let's talk about kind of the problem space here and why this is something worth talking about anyway. Hopefully, you should be aware that secrets are out there, and if you have a high-value application, chances are people are trying to steal them. There has been research in this space before, and it's estimated that around 55% of apps have some form of hard-coded secret, and I'm sure many of you in the audience would fall into that category. When it comes to the kind of secrets that are in your apps, the most common ones that we seem to find are surrounding kind of Google API keys, Firebase credentials, Facebook credentials, and so on and so forth. Although secrets can take many, many different forms. I'm sure you have APIs that you use, and many that you can think of off the top of your head. And to some extent, some of this is problematic, some of it isn't. It really depends on the level of risk and depends on kind of the functionality that the secrets provide. So on that kind of note, what is the problem? What could possibly go wrong? Well, I'm glad you asked. Let's talk about Firebase. Hands up if you're using Firebase. Thank you. And hands up if you like audience participation. Ben, yes, I know you do. Yeah, so Firebase is very common. Very common use in our apps. Around 30% of apps on the Play Store use it, although I'm sure that number is higher. I did find this white paper from 2021, so it's quite out of date, but it said at the time 30% of apps use Firebase, so I'm sure that number is much higher now. And the security team at Comparitech found that of that 30%, around 5% of those actually exposed data in one way or another. And that's because certain credentials were hard-coded in the app, and researchers were able to kind of reverse engineer applications that were ignoring security best practices and expose a whole range of data. So things such as Firestore. Firestore, for those that don't know, is kind of online databases, and many people, for whatever reason, were storing all sorts of crazy credentials in their databases in Firebase. There was one example I believe I read about where people were saving not only passwords in plain text, but also their attempted passwords in plain text. So even if the user didn't outright give you your password, you could probably reverse engineer that and figure out what they were trying to type anyway. As all of you should know, if you're all here at a mobile security talk, which is great, which means you're interested in it, you should all know that hopefully reverse engineering applications, especially Android applications, is incredibly easy and to some extent can even be automated. So yeah, if you have kind of Firebase in your app and you're not following best security practices, then this could be you. Another great example of kind of a very, very commonly exploited secret, things to do with AWS, Amazon Web Services. We have keys for those, and Amazon, as any major kind of cloud provider has 1,000,001 different offerings. Some things include kind of AWS web storage keys, similar stuff to Firebase, where they allow for databases, S3 buckets, etc. And exposed AWS keys are another kind of critical fail point for many big companies. You may have heard of kind of leaks for Verizon, which are a mobile provider in the US, WWE, which is the wrestling, not the Save the Pandas, Uber, who do cars or something, I've heard of them, and there's other companies that have kind of succumbed to massive breaches because of AWS credentials leaking. But those two kind of things aside, kind of more generally speaking, what's kind of potentially at risk, I think they can kind of be categorized as such. So the first thing, if your credentials or your secrets leak, you immediately risk the stability of your application. So malicious actors might be able to take your credentials, your secrets, and perform perhaps denial of service style attacks or on the APIs you use. And then that kind of can have follow-on implications, such as financials implications. You know, if you are paying for a particular service that uses an API key, and a malicious actor gets hold of it, they could perhaps run up your rate limits and actually cause you financial issues by being charged more than your actual usage really is. Reputation, that's a big problem, right? If you get hacked, your reputation is definitely at stake. Nobody wants to be using an application they know is insecure. So if you've not followed security best practices, then you're going to kind of, lose a little bit of rep, at least with me as well. And obviously security, if you've not followed security best practices, that might not be the only thing you're exposing. API keys, secrets is one aspect, but if you're not following security best practices, there may be a whole other load of things to exploit as well. And what is most potentially at risk, I guess, is your own job. If you do something, you've messed up so badly, then you're getting the sack, and nobody wants that, right? So if this is you right now, you're thinking, oh, that's me, don't sweat. This is kind of why I'm here. We're going to talk about it, and we're going to start talking about how we can kind of clean things up. My first very top tip is don't store secrets in your code base, which is, very easy to say, but what does that actually mean? Now, don't do a show of hands for this, because this isn't a good idea to show, but how many of these kind of apply to you? Do you have secrets hard-coded in files, maybe your Gradle files, Kotlin files, etc.? Maybe you have secrets that are stored in version control. Maybe they're not in your application anymore, but do you know if they were in the past? Exactly. If you don't know if your Git history contains secrets, if you have an application that's been around for a while, how are you totally sure that you're not exposing something in your Git history? And what is your current process for detecting secrets in your code base? What if a new developer joins your team and adds loads of secret credentials? Is that going to be good? Probably not, right? So let's tick these off one by one. Let's go through and kind of figure out some strategies and some tools we can use to solve this. The very first one, hopefully some of you have seen this before, this is the Secrets Gradle plugin for Android. This is an official, yes it is an official Gradle plugin, and what this allows you to do is essentially configure a secrets.property file within your code base, which will then, at kind of compile time, take that secrets property file and bundle them into the application. The secrets can be bundled in via build config or through XML, and it also allows you to add a dummy.properties file. So what you actually commit into your code base is the dummy file, so basically what you need to get the application to run, so it will compile. But kind of locally on your machine or on your CI, you generate a secret property file which should be in your gitignore file. So what this actually then looks like is something like this. It was kind of built with Google Maps in mind, so if you're using Google Maps, you've probably used this already. For example, if you have the Google Maps API key in your properties file, you can then access it, like I said, via build config or the XML. So with all things, there are pros and cons. The first pro of this is that this is practically something you could do immediately. It's the most simple integration possible for Android apps. It also removes the real secrets from your current code base, so you're no longer committing those secrets. You're excluding your actual production secrets.properties file via the git ignore, so this is no longer a problem. It's also an official solution. Hooray, we love official solutions, so thank you, Google, for that. It's the recommended approach, so if you're kind of not doing this and it's relevant, then definitely use it. And it's also CI friendly, so you can definitely easily generate a properties file in a way that you can use on your CI. There are, of course, some disadvantages. The first one being this still bakes secrets into your apps, which we'll get to. We'll talk about that in a bit. It also requires you to share your real secrets file with all developers. So, yeah, you can't compile the app unless you've got the real secrets file, which means that you have to store the real secrets file, and it's a chicken and egg problem. Where are you storing that, right? There's also no encryption, obfuscation, etc. So whatever secrets you use are the ones that are bundled into the application. So yeah, we can tick the first bit off of our list. This is one approach for kind of secrets hard-coded in files. We can remove them and put them into a file that's no longer committed. Sorry, let's go back. Yeah, so next up, kind of what if your secrets are currently stored in version control? Well, there's one way, or in your code base even, there's one way that you can kind of find this out very quickly. There's a tool called GitLeaks. I highly recommend that you give this a go. GitLeaks is a command line tool that essentially does static analysis on your code. It searches your Git repos for secrets and spits them out and tells you where the secrets are located. And yeah, just points out any kind of issues that you might have within your code base. It handles many common secrets and different secret types, things like if you've got hard-coded JWT tokens, AWS keys, Google Cloud keys, etc. And the good thing is, as well, is it's completely configurable. So if it doesn't have the key type that you want, you can add it. What's really nice about GitLeaks is it also comes as a GitHub action and a pre-commit hook. So it's something that you can integrate into most projects, not even just Android projects. This can be any project whatsoever. It's kind of robust enough to be used across practically anything. So again, the kind of pros and cons with GitLeaks is that yes, it integrates into practically every type of project. It's something that you can fit into your CI if you use GitHub Actions. It's something that you can literally start doing today. It scans all your Git history, so you don't have to, which is really, really nice. Again, the configurability aspect means that you are able to then go and add any kind of bespoke API keys. If you are using kind of a bespoke API key for a particular service that you need to find, you should be able to configure rules that find them and check your history for them. And like I said, it has many, many different ways to fit into your workflow. I guess the cons are that it isn't mobile specific. So one of the cons is that it is, one of the pros is that it isn't specific, and the other con is it's not. So it's it's tailored to be generic, which might work for you, or it might not be, specific enough for you. But again, configurability means that that's okay. It does occasionally, for me at least, provide quite a lot of false positives, so you have to be kind of mindful, if it spits out results, are they ones you actually care about? And actually, this tool doesn't remove secrets, it just detects them. So this tool is very good for being a warning flag to say, hey, there's secrets in the code, but then you need to actually action that afterwards. So yeah, let's kind of talk about that now. So we know now that we can find a way of checking our Git history if it contains secrets or not, but we now need to actually go back in time and check our Git history and remove them. So how do we rewrite history? Well, I'm glad you asked. There's multiple different ways you can do this. The first way is through Git itself. You can use git filter branch. Git filter branch, there's a very good talk by my friend Ben, who is sat at the front here. You may have seen it at previous DroidCons. Git filter branch is one option. There are also community written tools. There's Git filter repo and BFG. I'm going to cover those two in a second, but if you do want to know about Git filter branch, as I said, Ben has done a great slide. This is lifted straight from Ben's talk. I highly recommend that you watch Ben's talk from Android Makers last year. Yeah, last year. Wow, time flies. Yeah, highly recommend you watch that if you want to learn about Git filter branch. To be honest, Git filter branch is a viable option, but it's not kind of tailored for this particular use case, so it can be quite finicky, and I highly recommend that you kind of maybe use 2 of the other options available. The first one is git filter repo, which is a really nice alternative. It's written in Python, so you've got to kind of be wary that that is something that you would need to introduce into your stack. And the whole idea of git filter branch is what it does is you create a passwords.txt file. And this passwords.txt file is essentially a list of strings that you want to remove from your application. From your Git history. So let's say that you've got a particular API key, a particular phrase, a particular whatever secret that you want to remove. You add it to a passwords.txt file, and you run the command that's on screen there, git filter repo replace text with your file. And what you do is you hit enter and you go get some lunch because it takes quite a long time. It really depends on your repo size. So if you've got quite a small app, maybe it's a few minutes. If you've got a huge app that's been around for many years, even decades, yeah, you can take a day off and your manager won't mind because you're technically working. So what that will do is that will go through all of your Git history. It will find that string and it will replace it with a kind of redacted string. BFG is another option. Some of you might have heard of this one before. This one's been around a little bit longer. It works exactly the same way. So it's the one advantage I would say over the git filter repo is that this BFG is a jar file, so it's kind of JVM. We're all kind of hopefully working in a JVM world, so should fit into our stack quite nicely. And it works exactly the same way. You create a passwords branch, a passwords file. You run it. Again, the command is right there. It's practically word for word the same. And you go and get some dinner because at this point you've already had lunch. So yeah, go get dinner. It takes again a little bit of a while to do. But let's actually visualize what this looks like. It's all talk, and let's have a look. So in my first example, I've got a secret. It's handily called my secret. If I create a passwords file with that in and then run BFG, what that will do is it will go through my Git history, and when I later check, the history afterwards, you can nicely see that it's been removed, which is fantastic. So as of that point, yeah, my secrets have been removed from my local repo. So let's talk about the pros and cons of rewriting history. The pros are, it is highly performant. The two community tools are written in a way with this kind of use case in mind, so it's a lot more performant than git filter repo. And it is tailored to, like I say, to remove secrets. So there are other uses for these tools. So BFG can also be used to remove really large files. If you have really large files that are making your repo, very difficult to maintain, BFG is another option for that. And git filter repo actually was inspired by BFG, so has a few more features here and there as well. The one thing that you should note that's different between the two is that BFG doesn't modify the contents of your latest commit. So that will essentially mean that the secrets aren't removed from your most recent commit. And the reason that is because it doesn't want to break your code, whereas git filter repo doesn't care. It's just going to do it. It's just going to replace everything, including your latest commit, and your project's going to break, and you have to deal with it. That's fine. The other reason I like BFG is because I didn't realize it's also named after the ultimate weapon in Doom, which is cool. As with anything, when it comes to kind of Git, here be dragons, you've got to be careful. Rewriting history is dangerous. It will almost certainly break your code base. It also requires all clones of your code base to have these changes. So that means you're going to need to speak to each and every developer on your team and say, hey, I've just done a Git force push, and you're going to need to pull the repo again. And yeah, you need to make sure that that's kind of communicated effectively. And it also takes a hell of a long time for large code bases, but it's worth it. We want to remove those secrets, right? So we have now kind of got to the point where we can tick off our first kind of 3 common code base issues that we might face. But let's kind of now think about kind of a process. How can we start detecting secrets in our code base? And what might be a good strategy to kind of bring this into your organization? So I present Cooking with Ed. This is a recipe for a secret-free code base. So What you're going to want to do first is you're going to want to run GitLeaks. We've gone through that, why that's good. That's going to tell us where all of our secrets are. What we're going to then do is we're going to migrate any of those secrets to the Gradle Secrets plugin, so we can remove them from our files. We're then going to use BFG or Git filter repo to clean up the mess behind us, make sure that we're not committing any of these strings or secrets in our code base. We're going to bake it for 180 degrees, sprinkle these tools into our CI and processes, and then serve the fresh code base to our very hungry developers via a Git push force all. So yeah, this is a really quick, maybe not quick, but a really simple kind of flow to follow if you want to kind of remove secrets from your code base as of today. Cool, all right, let's talk about the next step, which is kind of securing our secrets. Yeah, this is me. I have done this before where I've been asleep and I've realized that I've actually hard-baked stuff into my app. So as we've kind of discussed, you know, things like Google Maps, if you are using some of these tools, we're still baking into these applications our code, our API keys and our secrets. One of the most common ones, and I think I better address this now, is Firebase and Google, and I'm asked this a lot, is that most of us here, we all have Google service JSON files, and what do we do? Should we commit them? Should we not? The official answer, as far as I'm aware, is that these are totally fine to expose and commit into your code bases, but you must restrict the API keys. And what I mean by that is you must go and visit the Google Cloud and Firebase console, and you must invoke the principle of least privilege. The principle of least privilege is the concept that a user should only have access to what they absolutely need to perform kind of the functions that you have within your applications. So when basically lock your API keys down to the minimum APIs that they actually need to expose. And to do that, you do this. You go to Google Cloud or Firebase console. You make sure that you have restricted your application. You can do it for Android by going and putting your signing fingerprint, your SHA-1 for your particular package name, and also then restrict the key further by making sure you select the APIs your API key can access. So in this case, I've got my com.example app, I've got its signing fingerprint, and I've restricted the API key that it uses to a number of APIs, only 5. If there's one takeaway today, it's to double check this, because I have worked at companies before, which will remain nameless, where I have checked and we have had totally unrestricted API keys for 10 years. So please do go and check that you need to, you do need to do this, but please don't do it now because it'll be distracting. Well, what about any other secrets, okay? So we've still got secrets hard baked into the app. How do we kind of deal with that? There are kind of options on the market. One of those is DexGuard by GuardSquare. Unfortunately, this is a paid solution, so this is not free, but they do offer a solution based kind of off ProGuard that allows you to encrypt certain classes and certain strings, and it's quite easy to do. It's a very simple, if you've done kind of ProGuard or R8 before, this should be hopefully a familiar syntax. And you would add this to classes where you want to encrypt particular strings. They won't tell me how they do it because it's magic and a trade secret. So I've been told it is magic. But you really want to also be utilizing other DexGuard features such as runtime application security protection to prevent kind of attacks on your app whilst it's running. So DexGuard is much more than just kind of making secrets encrypted. It does a whole load of other stuff, but this is a viable option. As I said, it obfuscates secrets. It makes it way harder to reverse engineer. DexGuard, I think, is probably used by a lot of major players in the mobile space, so it's tried and tested. It provides many different features, and GuardSquare support is great. They're not paying me to say that. It is pretty good. They're very nice people. There are other tools on the market, I should add, but they do a good job. With DexGuard for sure. It is a paid tool, so yeah, obviously not for everyone. If you're an indie developer, it's unlikely you're probably going to want to pay for it. Also, just using it for this use case is definitely overkill, but it, again, is a viable option. And like I say, other competitors do exist, so please do your own research. The good news is, if you're cheap, a bit like me, there are also free tools. There's plenty out there. There's three that I'm going to kind of highlight now. There's Hidden Secrets Gradle plugin, which is a Gradle plugin that utilizes under the hood the NDK. There's also ByteMask, which is similar but opts for a kind of KSP code gen approach. And then there's Secret as well, which is a Kotlin multi-platform plugin. So if you're kind of using multi-platform, then maybe that's an option for you. And that also utilizes the NDK. And what these tools all roughly do is something like this. You supply a secret. In this case, this is Hidden Secrets Gradle plugin. You provide a secret, and what it will do behind the scenes is essentially try its best to obfuscate it in your app to make it more difficult for potential attackers to be able to reverse engineer your application and find your secrets. So yeah, in this case, it's using the NDK. You can kind of see here that you have to load a secrets library that is automatically generated, and the output from the tool is basically this JNI call with the obfuscated secret. It's a bit small. I don't know if people in the back can see that, but yeah, it's essentially tried to move the secret into bytes that are also encrypted. So what's pros and cons of this? I guess the pros and cons of obfuscation plugins are that they obscure the secrets in your app. So yes, you still have secrets hard baked into your app, but at least they're obfuscated. The setup for this is really, really straightforward. It does make it more difficult to reverse engineer. So you should definitely, if you are looking to make it more difficult for hackers to get your secrets, this is a definite good option. And as it's free, it's also a good option for small projects, hobbyists, or indie developers. However, it's still very possible to reverse engineer. I would probably not recommend you using this approach if you are working for a bank or something that is highly regulated. It can also add a dependency on the NDK, so that does have overhead associated with it. And like I say, still probably not good enough for most large-scale apps, but certainly a viable option. So let's go back to cooking with me. So if you want a recipe for better hard-baked secrets, you should always restrict API keys whenever possible. So if you're using any third-party service that allows you to restrict your API keys, please make sure you are following that and doing it the best you can. Use the tools that we've covered, whether that's DexGuard, whether it's the kind of community tools out there, to do whatever kind of works for your use case. Do note that using the NDK is not a silver bullet. It will not solve all your problems, but it is a common kind of approach that is used sometimes. Baking secrets into the app is always a risk, and basically don't get burned. This is something that is still a problem, even if there are solutions for obfuscation. Which kind of leads me to tip 3, get rid of your secrets. Just don't have any secrets, then there's no problem, right? Well, duh, that's probably what you're thinking right now. How do you do that? Well, one common approach is a kind of architecture approach where it's a back-end driven proxy service. So the idea is you have your mobile application and you have some form of proxy server that you use, you control, and the idea is that you fetch any kind of requests that you make to a particular third-party API, they go through your server. So the server is the one that is making the third-party request, and it's supplying the response back to your application. So the idea is you pass, whatever, API.yourdomain, whatever, it goes off to the particular API and comes back with that proxied response. So your app is never talking directly to the third party. All of the secrets are, in fact, now in your proxy server. So you don't have any secrets in your application. It's now your back-end team's problem, and you can rest easy at night. Now, this isn't the perfect solution. This can still be very, very easily abused. One such way is having non-legit calls to the service. You could basically automate it. So if an attacker finds out you have this proxy service, you got to make sure it's an authenticated call or there's some level of security there. Otherwise, you can just script it, or you can just hijack it to basically reuse the API third party however you want. It also has, when we're talking about backend has a whole load of other kind of issues associated with it, things such as denial of service. So, you don't want users to be able to kind of, knock your proxy service offline. And there's also kind of man-in-the-middle style attacks where you can potentially, intercept things if you know what you're doing to access kind of sensitive data when it's coming back from the API service that you're using. So, we need to secure it. And the way that we would secure it is, first of all, doing something that we're hopefully all doing already, which is communicating over HTTPS and SSL. And then also making sure that we authenticate the calls to the proxy service. So we are a legitimate user accessing our service legitimately by using short revocable tokens, which we'll talk about in a second, and rate limiting. So a lot of this is kind of back-end stuff, maybe not stuff for mobile developers to worry about, but certainly something you can then make sure is a checklist that your back-end developers are following. And of course, yeah, remember principle of least privilege. You want to make sure that your back-end is only fetching the data that you actually need for the user's use case. One additional thing that we can do and kind of add into the mix here is device attestation. Attestation is the process of checking that your interactions and server requests are coming from a genuine app binary running on a genuine device to make sure that we're kind of only serving legitimate users content. And kind of the most common form of device attestation that we have at the moment is through the Play Integrity API. There is a really great talk on Google I/O, I think 2024, it is 24, I've put it there, regarding kind of safeguarding user security. I highly recommend you watch this. It's a really great talk. We'll talk a lot about kind of how the Play Integrity API can fit into your ecosystem. And like I say, what this essentially will do, if we add it into this kind of API proxy service flow, will ensure that only legitimate devices can have access to our APIs and also block any malicious requests. So what does that kind of look like? It looks a little bit like this, which is, yeah, I'm not very good at diagrams, and this is a little bit of a mess. They call me spaghetti code for a reason, right? This is a bit of a mess, right? So your app will talk to the Play Integrity API to check whether the device is legit. Then you will make a request to your proxy service, which will then check against the response that you got from the Play Integrity API, which will then also check your identity server to make sure you are a legitimate user. You can see kind of how this kind of can spiral quite quickly, and this is a very high-level overview of how much larger companies, your sort of big conglomerates, kind of approach this solution. So if you're a kind of small developer and not really working with millions of users, this might not be a problem. But if you're thinking about security at scale, you want to start moving towards this sort of architecture. But in general, kind of with many things in security, we need to kind of take into account the Swiss cheese model. Hopefully some of you have heard of this before, but Swiss cheese, for those that don't know, is the cheese with the holes in, right? The Swiss cheese model kind of states that if the more layers of security, which is represented by cheese, the less chance of an attack, represented by an arrow, will succeed, i.e. go through a significant line of holes. If there's kind of, there is a flaw in every layer of security, right? Nothing is perfect. There is no silver bullet. So the more layers you add, the less likely you are going to have a problem. So my takeaway from that would be more cheese, less problems, which in France I think we can all agree with, right? More cheese, less problems. We love cheese. So yeah, when it comes to kind of proxy services, again, there's kind of pros and cons. The first pro is probably the biggest one of all. It completely removes secrets from your app, right? So there are no more secrets. It's highly scalable, so your backend team can work with you to make this kind of service available, a huge scale, millions of users. This is how, many big companies do it. The good news is that the backend is traditionally more harder to exploit. It's not perfect, but it's traditionally harder to exploit than mobile. There's also increased logging and reporting, so it's a lot easier to see kind of the attacks when they're coming in because you're able to track them a lot easier. And now we also control the API between the front and back end. So if you think of that kind of original slide with the proxy service, when we are calling our proxy server, that API we control, and we also control the API coming back. So we can get, if we want data in a particular format, we can then kind of control that two-way flow now, which is really, really nice. The cons with this obviously requires much more effort. It also requires talking to back-end people. So yeah, sorry about that, but you do have to talk to them sometimes. And this would be a very good idea to do so. It also increases latency. If you think that there's much more kind of data being transferred, you've got to then talk to your server, that's then got to talk to a third party, that's then got to come back, and then you've got to there's latency, right? It's not quick. There is also now a single point of failure. If your proxy server goes down, you can't access all of your third-party APIs, which is problematic. And again, this is kind of big tech friendly, but not easy to achieve for most. So yeah, highly recommend that if you're in a big team already, that you probably are already doing this, or you need to talk to many people to get it started. And in reality, my diagram was very bad, and it's way more complex. Let's do some more cooking. So yeah, let's talk about how we cook a near-perfect application, which is the best we can really do. So a recipe for a near-perfect application is we first of all remove all the secrets from the app. As we've discussed in all the previous steps. We then provide their functionality via a proxy service that we can control. We obviously rate limit that to make sure that we're not seeing that abused. And then we add device attestation to ensure that only real devices and real users can access our service. And then we apply Swiss cheese generously because we love cheese, right? Originally, I was going to stop here. I was going to go through and say, that's it. But wait, there's more. Billy Mays. Anyone who know who Billy Mays is? He's very famous, apparently. When I've done this talk before, there's always one question at the end that people ask. They say, excuse me, what about my APIs, access tokens? And I go, oh, yeah, sorry, I forgot about that. No, I've remembered this time, so you're very lucky. Let's quickly talk about API access tokens. If we are an authenticated user in our app, it's highly likely that we have some form of API access token, and they probably fall into two categories. The first one being the access token, which is used on all of your authenticated APIs, and the refresh token, which is the token that is used to regenerate the access token. So your access token will have a shelf life, and the refresh token will say, okay, once that shelf life is over, use this token to be able to generate me a new one. They both have their kind of risks. The first one on the access token side is really dependent on your access token scope. So kind of what does it allow the user to do? And also the lifespan. How long does that access token last? Is it 5 minutes? Is it an hour? Is it 24 hours? Is it longer? Hopefully not, but maybe it is. And then refresh tokens, again, have different lifespans and scopes, but they do tend to be longer lived because you need them to be able to refresh your access token. But the real danger with a refresh token is that they can then be used to generate a new access token, which means that if a user has lost access, a malicious user can use a refresh token to regain access. So where am I going with this? There's some do's and don'ts when it comes to API access tokens. The first one, when it comes to API access tokens, is to use as shorter life as possible. So, well, as feasible for your use case. So that might be maybe 5 to 60 minutes. You also want to make sure that your refresh tokens are revocable. So you're using maybe something like JWT. Your backend team will know a lot more about this, but hopefully, yeah, you're using a kind of token that is revocable. So if anything goes wrong, you can revoke the token, and the server knows immediately not to kind of give you any more information and to send some 401s. Regarding 401s, it's very important that you respect HTTP 401s. So if you receive a 401, log the user out, for crying out loud. If the user is unauthenticated and unauthorized, then they should be, you should basically treat that as a sign that the user should be logged out and forced to re-log in. It's also important that you should rate limit kind of token refresh endpoints and invalidate kind of any dodgy looking sessions. Now, dodgy looking sessions in air quotes, because you need to be kind of sensible about this, like what does that look like? Again, talking with your security team is probably a good idea here to make sure that you are kind of thinking this through. And the other kind of, I guess kind of what we really wanted to get to is, okay, what do we do about these tokens? How do we actually look after them? The answer I'm going to give is that you can store them securely using the key store or encrypted shared preferences. Now, whether you want to or not, is another question, because this is, first of all, still not 100% foolproof. If you are using encrypted shared preferences, that was recently deprecated, and by recently, it was yesterday. So that has now officially been deprecated. And kind of, if you're using encrypted shared preferences without things like runtime application security protection, like you're still vulnerable to being able to have those kind of preferences accessed, either in memory or at runtime, so it's not a silver bullet again. And then you've got to really think about what are the attack vectors we really care about here, like man in the middle. This has got nothing to do with how we store the tokens, like that's how we transmit data. So is that something we're worried about? If so, then this talk isn't for you, that's another problem altogether. Or is the device need to be in the hands of the attacker, which presents a whole range of other problems, right? So if our attack vector that we need to be concerned about requires physical access to the device, is encrypted shared preferences going to solve that problem? Probably not, right? So yeah, sorry, this slide was thrown together on the train here, so I apologize, probably should add a little bit more here, but hopefully, that does cover a little bit about what I've been asked about before. So, in summary, we've made it. Well done, everyone. This is now your plan to have safer secrets. You want to, first of all, erase all historic secrets from your repo. We've gone through that. You want to always restrict your API keys if possible. I'm hoping that you're all going to go on Firebase and just do a quick double check to make sure you're doing that after this. You can certainly obfuscate to add an extra level of security if you want to use DexGuard, if you're willing to pay for it, or if you want to use other solutions, such as community-led ones. That does add an extra layer of security. You should definitely consider device attestation, more generally speaking anyway, to make sure that all of your users are legit. You want to be aware that most apps are baking in secrets, so just be sensible. If you can, remove all the secrets and proxy calls to remove them completely. And the last little thing I've shoehorned in there as well is to make sure you're using short-lived access tokens and consider secure storage for them. Whew. That's it, thank you. My name's Ed. You can find all of my stuff on spaghetti.dev/talks. I talk a lot about mobile security, usually at kind of 2x speed like this, but thank you so much for having me, and bon appetit. Lovely. I think we have a little bit of time for questions if anyone wants to stick around. We've got one straight away. Straight off the bat. Let me just have a quick sip of water. Go ahead.
First, thanks for the presentation. It was very, very good. I learned a lot of stuff, especially regarding removing the leaked secrets from the Git history. I had this problem in a very personal project some years ago, and I had to just delete the repo and make a new one again. Now the question I have is regarding the encrypted share preferences. I have done a migration for my company like last year, and actually I found it was deprecated not officially, but in some dark place in the documentation like December last year. But why I originally migrated to this is because dealing with the cipher directly on the key store directly brought me many exceptions for the users, like a bad tag exception and such stuff. And I had much less exception dealing with the encrypted chat preferences. And now that it is officially deprecated, do you have any alternative or whatsoever except dealing directly with the key store and whatsoever? I'm just, yeah.
Yeah, I had a feeling that there still would be a question about encrypted shared preferences. It's a funny one, right? So I think the official line from Google, and bearing in mind I'm not official Google, so you should double check this, but I think their official stance is it's deprecated. You should use either direct access to the key store yourself, which again is a bit problematic. You need to, it's not straightforward, or because of, I believe, as of Android 10, I want to say, the device, I believe, is encrypted by default. I think their official recommendation is just use shared preferences. If your concern is that, somebody's going to be able to access the shared preferences on the device, that means that they have the device physically to hand. It means that they are going to be able to, run all sorts of, things like hooks, Frida, whatever, to be able to kind of, do runtime style attacks. So, you might be, if they're able to access the stuff in memory anyway, then, what good is encrypted shared preferences? Now, the kind of flip side to that is that there are compliance reasons. If you work in banking, if you work in healthcare, if you work, there are extra levels of rules. And I think what I would say in that case is just use encrypted shared preferences. If it's not going away. It's still there. The API is still available. It is just deprecated. You just have to bear in mind that it's not receiving any updates. And to be honest, it hasn't received any updates at this point for a year anyway. So if you're okay using it right now, continue using it. That would be what I would suggest. But yeah, whether they actually come out and say any more, I have no idea. It's a good question, but hopefully that answers your question. If encrypted shared preference is working for you, use it. Thank you.
Hello, thank you for the talk. I wanted to ask about that proxy server. Like, how does it ensure security? Because basically anything may call like a method on that proxy server and pretend it's you, and they have like no keys to prove it's you.
Well, you would first of all use authentication, so you would have some form of authenticated call to the app, so you would presumably use kind of tokens that we've discussed to make a authenticated call to the API. As we discussed, we'd also do device attestation, so you'd also make sure that you are kind of calling from a legitimate phone as a legitimate Android user. And I think the main takeaway I would take away from it is that what it really does is it moves the secrets away from being hard-baked in your application and is then on the server side. So it's no longer your problem. As a mobile developer, we don't have to worry about, about things like, the API keys. And there are other benefits as well, actually. I should have mentioned this as well. If your API keys rotate, if you need to regularly rotate API keys, you don't have to re-release your application anymore because you're proxying it through a server. That can be done server side, and all of your users will be using the new version straight away. So there's kind of other pros and cons to it. Again, it's Swiss cheese, right? It's adding kind of more levels and extra levels of security. Hello.
Hello. Thank you for the press.
No problem.
So my question is we can talk about a secure application that I am as developer that give a third part to be a part of the security of my app. For example, here you present or you mentioned that you can for the Google Play service I should to provide the package and generate the key and check to the unstructured key to ensure that my app is secure. Whenever that in the presentation or the workshop on Google that present the benefit, but we don't know as a developer how manage the thing behind this service. So is that recommended to use those kind of API or service to protect my app?
So I understand your question. Your question is regarding things like Google, where they have on the Firebase you are using is your question, should we use that or not? Or
how is the safety to give to make a third party to be a part of the security of my app?
Yeah, so okay, I'm trying to think how I'm going to answer this, because it's a good question. So yeah, I mean, with many things, there's a level of trust. Whenever you use a third party for anything, there is a level of trust there, right? If you are kind of interacting between your service and their service, you have to kind of trust that, both parties are acting in good faith and that there's, security kind of considerations on both sides. I personally believe that Google are doing the right sort of thing, and if you are using a third party like Google and they offer the ability to be able to lock down API keys, I trust that they're doing that and that their security is working as expected. If that is a concern of yours, I guess the alternative is you don't use the third parties. It's always worth investigating any third party that you add into the application. You should always do a security audit to make sure you are comfortable adding any third parties to your application. But in terms of kind of, do you trust that third parties are doing the right thing? I guess that's your decision for you and your cybersecurity team. I personally have no problems with Firebase, and I believe that they are doing what they say they're doing. So yeah, I don't know if that actually answered your question, but again, I'll happily stick around afterwards and answer it a bit more. I think actually, looking at the time, I've got to be quiet. So thank you everyone for coming. I really appreciate it, and hope to see you again.